In 4.2, we're graphing polynomial functions, and right here for us we have a list of some specific steps, some really by-the-book steps that will give us an exact graph of a polynomial function. Now we can start off by using the leading term to determine our end behavior, and then we can find the zeros by setting the function equal to 0 and setting most of the time what we'll have to do with the function, we'll have to factor the function and set each factor equal to 0 and solve for x. In step 3, you use those zeros that you just found to divide that axis into intervals, and then in step 4 we find the y-intercept by setting the x values in the function equal to 0 and solving for y. And then if necessary, we find additional function values to determine a more general specific shape of the graph. And then to partially check, we can use the fact that the graph has at most n x-intercepts and at most n minus 1 turning points. Multiplicity of zeros can also be considered in order to check where the graph crosses or is tangent to the x-axis. Now in our first example, we have h of x equal to negative 2x to the fourth plus 3x cubed. I just gave you that very specific list of steps to give us an exact graph of the function, but I'm just going to follow the steps that it has for me right here in front of me. We don't always have to get a specific exact graph. Sometimes we can just take bits and pieces of what we know and answer the question. So for this specific problem, I'm just going to do a generic rough sketch of the graph. It won't be exact. So to start off, the first part asks me to find the leading term and use the test to determine the end behavior. The leading term is negative 2x to the fourth. X to the highest power, so x to the fourth power, negative 2x to the fourth. Okay, the fact that that highest power is even tells me that the end behavior will go the same way. So they're either going to both be going up or both be going down. And since the 2 is negative, that tells me that the ends will both be going down. So to find the zeros in step 2, I take negative 2x to the fourth plus 3x cubed, and I set it equal to 0. I want to factor out, let's see, a GCF of x cubed, and I'm left with negative 2x plus 3. And I set both of these equal to 0. X cubed equals 0, so x equals 0. And then negative 2x plus 3 equals 0. So I move the 3 over by subtracting it from both sides, and I get that negative 2x equals negative 3, and then I can divide both sides by negative 2 and get that x equals 3 halves. In step 3, I'm determining my y-intercept by finding what h of 0 is. I'm basically just plugging 0 in for my x's there. So negative 2 times something to the fourth plus 3 times something cubed. Well, that something is going to be 0. That's what I'm plugging in. So 0 to the fourth is 0, 2 times 0 is 0, and 0 cubed is 0, and 3 times 0 is 0. So y equals 0. That y-intercept is 0, 0. So off of the 3 things that we've done, I can roughly sketch a graph of negative 2x to the fourth plus 3x cubed. I'm going to start off by graphing those zeros that we found in step 2, which is basically an x-intercept, and I found that the zeros were 0, so this function will go through the x-axis at 0 and 2/3. So if this is 1, then 2/3 will be about right here. And we said that our end behavior, that both of the arrows would be going down. So let's see how we can make this happen on our graph. I could start here going down and go through that point, come back through and go down again. Let's try that. So this is a rough sketch of this function. Notice our end behavior is correct. They're both going down. They're going the same direction because that leading term had a power of 4. That power was even. And its number out front was negative. So that meant they both went down. And then we crossed the x-axis at 0 and at 2/3. And our y-intercept was also at 0, so I had already plotted that point. And so we know that the graph will look something like this. Now in our next example, our function isn't set up in that standard form. I'll have to graph the polynomial function of x plus 1 times x minus 2 squared times x minus 4. Well, let's see here. I could write this as x plus 1 times x minus 2 times x minus 2 times x minus 4. And I can do that because when I square something, it's like multiplying it by itself, and that would be x minus 2 times x minus 2. So I'm not going to bother multiplying all these binomials, these 4 binomials together. I'm just worried about that leading term. And I know if I multiplied it out, my leading term would end up being x times x times x times x, which is x to the 4th. That's our leading term. So I can get that without multiplying the whole thing together. Just take those leading terms in each binomial and multiply them together, and that will be your leading term for the polynomial. So this leading term has a power of 4, which is even, so that tells me they're going the same direction, these two options, okay? And because this right here is positive, that means they're both going up. Finding the zeros, solving for g of x equals 0, is a lot easier with this one because it's factored for me. So x plus 1 equals 0, x minus 2 equals 0, and x minus 4 equals 0. Right here I get that x equals 2. It has a multiplicity of 2 because of it was squared. Whenever I have a multiplicity of 2, or my multiplicity is even, that means instead of crossing through the axis at x equals 2, it's sort of just going to touch it and move another direction. So we're just going to say, just for our benefit, whenever we're sketching the graph, we're just touching at x equals 2 because the multiplicity was even. Now for x plus 1 and x minus 4, whenever we solve those in just a second, its multiplicity is odd, which means it's going to cross through those points. So it's really easy to solve these, just like I solved x minus 2. I move that negative 1 over. I get that x equals negative 1. And right here I get that x equals positive 4. Now to determine the y-intercept, g of 0, I'm just going to plug 0 in for x. So that would be 0 plus 1. And then 0 minus 2 squared. And then 0 minus 4. Well, 0 plus 1 is 1. 0 minus 2 squared, it would be negative 2 squared, which is 4. And then 0 minus 4 is negative 4. So negative 4 times 4 times 1 is negative 16. So using these 3 bits of information, I'm going to start sketching my graph. I'm going to start off by using that step 2, what I found there, and plotting my zeros, which is basically an x-intercept. And I had one at negative 1, another at negative 2, and another at 4. Now, I know that at negative 1, we are going to cross because its multiplicity was odd. And at 4, we're going to cross as well. But at 2, we're just going to touch because its multiplicity was even. I'm going to graph our y-intercept, which I didn't do a good job of notating exactly what that was. Our y-intercept is, let's see right here, 0, negative 16. So since if you'll look on my graph paper, and it's probably the same on yours, I go to 0, negative 16, so negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I run out of room. I'm going to say this is negative 16 right here. I'm going to put a point right there. That's going to be my y-intercept. And I know that my end behavior looks something like this. They're going upward in the same direction. So I would have to start here, come down and cross through that y-intercept, touch and go the opposite direction, and then come back through this point right here and go up, finish upward. So let's sketch this thing out. And remember, we're touching and come back up to cross through that 4. And that's a basic sketch of our polynomial.